Today I'm going to tell you about the myths of science that William F. McComas talks about in his article, The Principal Elements of the Nature of Science, Dispelling the Myths. These myths I'll be telling you about are the most common myths about science that people today believe to be true, but in reality they are nothing like the nature of science and what science is really about. The first myth is hypotheses become theories that in turn become laws. Most people believe that as more evidence is collected, that there is a developmental sequence that follows, that we start at facts and observations, and as we increase evidence, it becomes a hypothesis, and then the hypothesis becomes a theory, and then finally becoming a law. But that is not true. There is a relationship between laws and theories, but it isn't that theories become laws. In fact, theories are the explanations of laws. Newton was able to explain the difference between theory and law using gravity. He discovered the law of gravity because he knew it did exist. But for now, there is no theory of gravity because he couldn't explain the cause of it. The second myth is scientific laws and other such ideas are absolute. Science is tentative, so people fault science for not being absolute. They believe that science should not have to be corrected. Most people question if there are really laws in the life sciences because they compare it to the physical sciences where the cause and effect are more securely linked, while life sciences have a probability factor in it, and limitations are placed on the use of these laws. The laws in the life sciences are not absolute due to these limitations and different rules for application, but they are still laws. The third myth is a hypothesis is an educated guess. Hypothesis really has at least 3 different definitions, which is why you should use the word hypothesis with caution. Generalizing hypotheses are tentative or trial laws that can become laws. Explanatory hypotheses are provisional theories that can become theories. Hypothesis in a laboratory setting means prediction, not an educated guess. The fourth myth is a general and universal scientific method exists. Most people believe that all scientists conducting research follows a common series of steps. The steps are first define the problem, then gather background information, next form a hypothesis, then make relevant observations, next test the hypothesis, then form conclusions, and finally report results. The way research journals are written makes it seem like scientists follow a universal scientific method, but it does not show the actual process in which the problem was investigated. Scientists use their imagination, creativity, prior knowledge, and perseverance to solve problems, not a general and universal scientific method. The fifth myth is evidence accumulated carefully will result in sure knowledge. Scientists use induction to collect and examine individual pieces of evidence until a law is discovered or a theory is invented. Even though evidence is very important, it does not guarantee that sure knowledge will be produced. Induction makes it impossible for scientists to produce laws and theories that will be guaranteed to be true forever, because it is impossible for scientists to make all observations for a certain situation. We make predictions based on the law, and if the prediction is correct, the law is supported, but it is not proven. If the prediction is wrong, the law should be questioned. The sixth myth is science and its methods provide absolute proof. Science is all about being revised when new information is presented. Evidence can support and validate a law or theory, but it will never prove those laws and theories to be true. The only knowledge that is true is when evidence proves a law or theory to be false. When laws and theories are proven to be false, they can be modified or removed. The seventh myth is science is procedural more than creative. Only the creativity of the scientists allows for the discovery of laws and the invention of theories. If there was a single scientific method, then 2 individuals with the same expertise would come to the same conclusion after looking at the same facts. Because creativity is a personal attribute, individuals coming to the same conclusion is not a guarantee. The majority of laboratory activities in the classroom are what we call cookbook labs, and they do not encourage creativity and doesn't show how science actually operates. The eighth myth is science and its methods can answer all questions. Some questions should not be asked of scientists. Science can't answer moral, ethical, aesthetic, social, and metaphysical questions, but it could provide some insights to these questions. Science is scientific ideas that are potentially falsifiable, like the law of gravity is a scientific law, because it can be made false if new evidence disproves it. The ninth myth is scientists are particularly objective. The myth may seem valid because scientists try to carefully analyze the evidence and come to a conclusion without being objective, but complete objectivity is impossible. Scientists are always searching for evidence that supports their ideas, making it less objective. Scientists hold preconceptions and biases about how the world operates, which makes it impossible to collect and interpret facts without any biases. Scientists' expectations is what influences them to decide what information is unimportant and what goes on the final report. Scientists work in this research tradition where it provides direction to the research, which may limit the investigation and objectivity. There is a chance that new ideas in science are rejected because of this research tradition, viewing the ideas as poor science. Some ideas were sun-centered solar system, warm-bloodedness in dinosaurs, the germ theory of disease, and continental drift. People didn't want to believe in these ideas, so they decided to reject them, until there was enough evidence where they couldn't deny the ideas any longer. The 10th myth is experiments are the principal route to scientific knowledge. Experimentation is not the only route to knowledge. Scientific knowledge can be gained by observation, analysis, speculation, library investigation, and experimentation. For example, in astronomy, discoveries are based on observations, not experiments. The 11th myth is scientific conclusions are reviewed for accuracy. Scientists don't review each other's experiments because they are too busy and research funds are limited to do these reviews. Scientific experiments are usually repeated because the scientific conclusion was attacked by the current research tradition. There is a pressure to produce new information rather than reproduce others' work, so it increases the possibility of errors going unnoticed, since repeating each other's experiments aren't happening often. The 12th myth is acceptance of new scientific knowledge is straightforward. The acceptance of a significant breakthrough is not as easy as people believe. Humans are the producers of new knowledge, and also the deciders of what counts as new knowledge. There is a peer review system that acts like a gatekeeper to new ideas, because if these ideas can't go into a journal, then it will never be accepted or denied. And if they go into a journal, they still have to pass the conference test to be accepted. The 13th myth is science models represent reality. Science is about answering questions about the natural world and getting as close to the truth as possible. Most people believe that the scientists' ideas and descriptions match reality. For example, the model used for atoms and molecules show them as tiny discrete balls with elastic collisions, even though no one has ever seen these tiny balls or seen their impacts. The model works, so it must be true, right? Well, a realist would say yes, while an instrumentalist would say yes as long as there is something to be gained from this model, otherwise no. We should think of models as useful fictions and not reality. The 14th myth is science and technology are identical. Most people believe that science and technology are the same, but they really aren't. Science is not necessarily practical like technology. Science is the pursuit of knowledge for the sake of knowledge, while technology is the exploitation and the production of a product, like a television, rockets, computers, and refrigerators. The 15th myth is science is a solitary pursuit. Most people believe that great scientific discoveries are made alone, by great scientists. Even the Nobel Prizes recognize individual scientists instead of a research team. But people who have studied scientists have shown that it is very rare for a scientific idea to come from one scientist, be validated by only that scientist, and accepted by the scientific community. Scientists work in research teams since science is too complex for one scientist to do alone, because of time constraints, intellectual capital, and financing. That's it for my lesson on the myths of science. I hope this has helped you understand some of the most common myths out there about what science is.